Today we're going to go a little further into the inverse trig functions. We're going to find some more exact values. Now in this first problem, we're asked to find the arc cosine of -half. And remember, the values that we're going to give are between 0 and pi for the cosine. And this happens to be a unit circle problem. So, because we know that there are x values of -half that we know on the unit circle, so I wouldn't give you a calculator for this. So, in this case, where is that x value, -half? I know that's somewhere in the second quadrant, and I know that's at 2 pi over 3. So what I have is I have the tangent, and the answer for the arc cosine of -half is 2 pi over 3. And then what I have to do is I have to find the tangent value at 2 pi over 3. Well, I know my x value is -1/2. My y value is √3 over 2 there. So then I just calculate tangent by taking √3 over 2 over 1/2, which happens to be negative, giving me √3. And I'm done. So it's great when it's on the unit circle. You can just take and find those values because you know them. So on this problem, you'll notice we have to find the exact value once again, except this time we aren't starting with an inverse. In the innermost parentheses, we're starting with an actual value. So this problem asked me to find the cosine of 7 pi over 6. Here's my unit circle. I know the x value at 7 pi over 6. √3 over 2.5 give me the point. They're both negative. So I know at this point I have to find the inverse sine of -√3 over 2. Now, the only problem I have now is that I can't state my angle as an angle in the third quadrant, because I know when I find inverse values for sine, they're between pi over 2 of the negative type and positive pi over 2. So therefore, I'm looking for an angle, if I want a negative value, in the fourth quadrant somewhere. But here's the change in this case. Notice I'm finding an inverse sine now instead of an inverse cosine. So rather than having an x value, I need my y value to be √3 over 2 in the fourth quadrant. Where is the y value, -√3 over 2 in the fourth quadrant? That's at -pi over 3. So that was a little change to the problem. Just know what you're trying to find, x's or y's. Now in this case, this is not a unit circle type problem because I have no idea where 5/13 is on the unit circle. So what I've always done is I've always taken things and said, all right, well, if I have some random angle, I can always make a ratio of sides up from a given triangle off the unit circle. I know this is like my hypotenuse or my radius, 13. I know this is like my y value of 5. This is special right triangle, 5, 12, 13, once again. And now what I'm asked to do is I'm asked to say, all right, well, I have some angle, theta, whose value is associated with an inverse sine of 5/13. Here's my theta value. So I'm asked to find the cotangent of this theta value. And if I look at my triangle, well, my cotangent is just my x value over my y value, and I have all of that within the picture. So I can just say my answer is 12/5. Likewise, let's go to another problem very similar to that. Somewhere on the unit circle, or not on the unit circle because I don't know where 5/3 is, so I take it off, and I say, well, this is the same as cosine of some theta value. Where is that theta value coming from? Well, I can make, since they're both positive, a first quadrant relationship. I know cosecant the hypotenuse, over the y value. And once again, special triangle 3, 4, 5. And I want to find the cosine of the angle theta. Where here's theta. The cosine of that is adjacent over the hypotenuse. So that's equal to 4/5. Pretty straightforward. Just have to draw yourself a triangle. Now, this is not so straightforward. All right? We're asked to find, first of all, what angle gives me a sine value of 2x, and then find the secant of that. There's no way I'm going to get an exact value because this is an expression. But what I do know is I have to find the secant of some theta value. And I know that if I have the arc sine equaling 2x, I can put my theta right here and say sine is equivalent to the opposite over the hypotenuse. And I'm going to say I'm on the unit circle because I don't know what x stands for. So I'll call my hypotenuse 1, call my opposite 2x, and then I can find a relationship to give me this horizontal value, which is going to help me find my secant. So what I have is I have a right triangle, 2x quantity squared, I'm going to call this w if you will, plus w squared is equal to 1 squared. Therefore I have w squared equals 1 minus 4x squared, and w is equal to the square root of 1 minus 4x squared. So this horizontal quantity is the square root of 1 minus 4x squared. If I want to find the secant, that's equal to the hypotenuse over the x value. The hypotenuse is, in this case, is 1 over an x value of 1 minus 4x squared. If I wanted to rationalize that, that's square root of 1 minus 4x squared over 1 minus 4x squared. And that's pretty much every type of problem you're going to see. Short one today. Do your lesson summary and fill out the My Math Lab.